Welcome to part 4 of our live training process here with our Force Induction K-Series G4x plug-and-play example. Now, in the last tutorial, we focused on doing the calibration process for part throttle cruise area of driving. This tutorial, we're going to be focusing on doing our full throttle tuning on our low cam of operation, or without VTEC enabled. So we're going to go through dialing in our fuel, our spark, our variable cam control, and as well as our per cylinder knock control. That's going to allow us to see the limits of our spark timing as we're dialing them in. This is going to be important whether you're going to be on a chassis dyno or not doing your calibration process. We're going to have a lot to cover. Let's jump in so we can check this out. Welcome back to our live training session here with our supercharged K-Series NSX. In the last tutorial, we looked at the calibration process for the part throttle cruise area of driving. Now we're ready to turn our attention in doing our full throttle tuning, specifically on our low cam of operation, or non-VTEC of operation. Now, the way we've set this calibration file up is that we have two volumetric efficiency tables. We have a VE table 1 for the low cam operation, or non-VTEC. VE table 2 is going to be for the high cam operation, or when VTEC is engaged. We specifically have it switching between table 1 and table 2 based on the VTEC activation status. Now, we've configured all of that, but in this case, we've disabled our VTEC. We're going to be focusing our effort on just low cam tuning in this tutorial, focusing on our wide open throttle process here for low cam. Now we're going to be integrating the closed loop correction in our calibration process in the tutorial, also taking a look at how we can integrate a knock sensor into the calibration process. This is going to be very, very important. If you don't have a chassis dyno, you really have no means of figuring out what your spark timing should be. If you follow along with what I show you in the tutorial here, utilizing a knock sensor and working within the knock control, you're going to be able to easily dial in your spark timing tables and know what is safe and what's not safe, whether the engine is knocking or not. We can do a per cylinder basis in terms of our knock control, and the G4x is extremely quick in its processing speed, so you can see very detailed knock information from the knock sensor. You just have to know what you're looking for. Again, we're going to cover that pretty heavily. Now, in addition to all of this, we're going to be taking a look at our variable cam control tuning, working with the variable cam control and figuring out what is going to be the optimized variable cam target as we're going from zero variable cam or no overlap and moving up in various variable cam movements. Now, we're going to go through a lot of detail here. So the first thing I want to go and talk about is taking a look quickly at our knock control. Now, we've turned it on, we've set it up, but we actually forgot one step when we were creating our base file. It's no big deal. We're going to take care of it now before we head into our full throttle tuning. So let's jump in here. I'm going to move from my fuel page here over into the knock control page. Now, into the knock control page, we have our knock set up here. Let's just go through some of the settings real quick. We have it set on ignition trim. It's only going to be pulling timing when we have any kind of knock event. I don't need it to do fuel, and we're sticking with the traditional knock control strategy. We do have another option here, normalized. We're going to cover that in another tutorial at another time, but in this case, we're just going to stick with the ignition trim because this is the older way from the G4 Plus and the earlier G4x software that works extremely well. I've used this on many cars, and the normalized mode I haven't had a whole lot of seat time with, so I'm going to stick with ignition trim right now, and then again we're going to have a separate tutorial looking at our normalized ignition. Let's go here and just choose our option here, ignition trims. The frequency channel, we have it set here for 4 to 10k hertz wideband type of signal. And this is a Bosch flat response, which means it's a wideband type of knock sensor. I can look at a large frequency range of knock sensor, the frequencies for the outputs for the knock sensor, and it'll work for a huge majority of engines because the frequency, the ringing frequency where knock happens at, is based on the bore size. When we're dealing with a flat response knock sensor, it's kind of a broadband type of sensor, so it can look at a variety of different frequency ranges and still pick up knock. We're going to talk about how we can distinguish what knock is, what's noise and what's knock in this tutorial, but we want to choose that for a Bosch flat response. Now, if you're going to be on an OEM knock sensor, you're going to want to probably choose one of these narrowband options. Now, on a bore size for an 86 mil bore for a K20 engine, you'll be between 6 and 7k hertz narrowband. The narrowband is meant more for a resonant style knock sensor where they're tuned specifically for the bore size of the engine. In this case, an OEM knock sensor from Honda would be a resonant style sensor. You would choose either 6 or 7k. I'd probably choose 7 because it's actually going to be a little bit closer to what it calculates at. I think it's about 6.6, 6.7 kilohertz if you ran the calculations through the bore size of the engine to figure out what the actual specific frequency would be. I think it would be about 6.7 kilohertz, if I remember correctly, for an 86 mil bore. we do see some other choices. One thing I want to mention is you have an engine that's extremely noisy. So you have an engine, you have a knock sensor fitted to it, and it has big cams, maybe it's built relatively loose, and it's getting a lot of noise in the signal, and it seems like it's almost unusable. What you can do is figure out where the normal frequency should be at. So let's just say it was 7K kilohertz. You would double the frequency, and you look at the second order of frequency, which can actually start to reduce some of the background noise and make the knock control more accurate. We don't have to worry about just saying, oh, let's turn off the knock sensor, we can't use it. You would literally go up here and choose something like 14 kilohertz. So you double your primary frequency, whatever you calculate based on the bore size. And we have a calculator in the training course. We have it in the knock control video. We talked about that. We talked about plugging in the bore size to figure out the exact, frequency based on the bore. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.